I see the comments and requests and I will act on them. Please remember to follow Geography World channel on Instagram and Facebook using the link shown on the screen. Please remember to like, share with your friends, and subscribe. For persons wishing to contact me privately, you may email me at geographyworld100@gmail.com. The link will be posted below.
Hi guys, welcome back to Geography World. For today's video, we'll be looking at the 2019 Cape Unit 2 Geography exam, and for this video, we'll be looking at question number 2. Question number 2, it looks at Module 1, and Part A to the question asks that we distinguish between adiabatic lapse rate and environmental lapse rate. Now, environmental lapse rate, it refers to the actual decrease in temperature with height in a column of stationary air in the troposphere of a specific area. So the actual decrease in temperature with altitude in a column of stationary air in the troposphere of a specific area. Now the air is heated from the bottom up and it cools at a rate of 6.5 degrees Celsius for every 1,000 meters of ascent at a given location. Now that was environmental lapse rate. The adiabatic lapse rates are the changes of temperature in a rising or sinking parcel of air as a result of expansion or compression of the air. There are two types of adiabatic lapse rate. You have the dry adiabatic lapse rate and you have the saturated adiabatic lapse rate. So the dry adiabatic lapse rate refers to the cooling of a dry parcel of air as it expands and rises up in the atmosphere at a rate of 10 degrees Celsius for every 1,000 meters of ascent, while the wet or saturated adiabatic lapse rate occurs when the rising parcel of air reaches dew point and the air is cooled until the water vapor present begins to condense. Now, because of this, the rate of cooling decreases to about 5 degrees Celsius with every 1,000 meters of ascent. Now, once you were able to differentiate between adiabatic and environmental lapse rate, 6 marks is yours. Part B to the question asks that we write an essay discussing why anabatic and katabatic winds occur in mountainous region, and we are to include a well-labeled diagram. So remember to include your well-labeled diagram. This could work. Now, it's an essay, so you have to have an introduction. So your introduction is basically just introducing us to the types of winds. So it could be something as simple as mountains can create localized winds referred to as anabatic and katabatic winds. Anabatic and katabatic winds form part of a microclimate of a mountain region, because remember that both types of wind help to basically determine the microclimate for that mountainous region. Now, after introducing the two types, you're going to go into your body of your research where you're basically going to discuss the two different types of wind. Now, on warm sunny days, incoming solar radiation from the sun, it warms up or heats up the slope and valley of the mountain. Due to the heating, the valley floor develops a relatively high pressure, while the peak and the higher slopes of the mountain develops low pressure. Now, during the daytime, wind may blow up the valley to the mountainside, so bring it from the valley up the mountainside. We call those valley breeze or anabatic winds. Now, as the cool valley breeze moves upward, it moderates the surface temperature, right? So the valleys are aid in the formation of a cumulus cloud in the daytime in mountainous region. So if you look closely, you can see the wind is moving from the valley up onto the slope of the mountain. Now, during the night, the air above the cold mountain slope will cool rapidly and create high pressure on the mountain, which will cause winds to blow down into the lower valley where there is low pressure. It is called Katabatic or mountain wind. So here, this is nighttime. The wind is blowing from the slopes down into the valley. So the mountain winds are the night winds, and these are stronger than the valley winds, or which are also called the day winds. Now, once you were able to basically differentiate between the two, then all you need to do is have your conclusion. Remember that your conclusion is just summarizing your main points. So it could be as simple as mountain regions have their own unique microclimates that are influenced by the anabatic and katabatic winds that affect the location. Something as simple as that, and you should be well on your way to 14 marks. Part C to the question asks that we outline 2 human factors that contribute to the development of tropical grasslands. Now, 2 human factors that basically contribute to the development of tropical grassland is, like, for example, abundant agricultural projects, which basically leaves bare unfertile soil. You have deforestation for housing. You have fire, which is caused by humans, which will remove tree vegetation, which will give rise to grasslands. The slash and burn method used for clearing the land as well. And we know that humans contribute to climate change, which brings about a change in weather conditions, such as less rainfall, which results in a longer drought period, hence encouraging the growth of grass, right? So these are just a few of the human factors that basically help to create grassland. Once you are able to just outline any two, then the marks should be yours. Part D to the question asks that we suggest 2 reasons why the characteristics of soil at the top of a slope are different from the characteristics of soil at the base of a slope. Now, the characteristics of soil at the top of the slope is different from the characteristics of the soil at the base of the slope because, one, due to leaching. And remember that leaching is the downward movement of materials or minerals in the soil profile, right? So it basically helps to create a distinct soil profile that has specific characteristics such as color. The color of the soil at the top of the slope tends to be lighter in color due to downward leaching, while soil in the lower areas they tend to have a darker color due to the accumulation of leach material. We can also speak about the angle or the steepness of the slope that determines the size of the particle. So finer materials or particles are often slide down slope, right? We can talk about, for example, if the feature is a plateau, those often have gentle gradient, which gives the soil similar characteristics as those at the base of the slope. The top of the slope is usually fully aerated while the base of some soil is waterlogged. The top of the slope is often infertile due to leaching while the base is fertile due to the accumulation of leach material. Now, once you were able to answer these 4 questions, then 30 marks should be yours.
We are at the end of this video. Thank you for watching, and please remember to like, share, subscribe, and turn on your post notification bell in order to receive more videos like these. Leave comments below suggesting topics that you would want me to present on. In the comment section below, comment the name of your school and the territory for a shout out in my next video. Until then, bye.